Hi, everyone. It's me. No one has shown up to the live session today. So what we're gonna do is I'm just gonna go over my homework assignment, and hopefully that'll help you all guide you through yours. Remember, for like the background, the theory behind why all this stuff is work, you really should read the book and take the notes, watch the video, watch Wendy's video. Okay, so here we go. I'm going to share my screen and we'll be off and running with today's assignment. So chapter 5 homework is only the one lesson this week. Maybe that's why no one showed up. But so we'll talk through these. Hope that everyone can see that. Let's double check. So I'm going to share my desktop. Okay. I'm assuming if we can't see that, then this whole video is going to be for naught. Okay. I usually have students check to make sure it's showing up. So discrete variable versus a continuous variable. A discrete, you can't have anything in the gaps. It's like number of credits you're all taking at LCC, right? You're either going to take probably 4 credits is the least, 5 credits, 6 credits. There's no gap between them. All right, continuous is like heights, right? There really are no two people that are the same height, right? So you could be any height between, I don't know, what are you, 20 inches when you're born, something like that, all the way up to 8 feet tall. Continuous. Okay, so the blood pressure of a group of students throughout the hour before the exam. That's interesting. So I'm going to say that the blood pressure really doesn't have. Let's see what happens if I may get marked incorrect. We'll see. I have somebody, thankfully. So maybe we'll see. Hi, Estelle. Hi, Estelle. I've already started because no one else showed up yet. So here we go. We're on number 1 on the assignment. I'm going to guess that blood pressure is discrete. I may be wrong. See, they're not telling me what the answer is. Okay. The temperature in degrees Fahrenheit through one day at the LA airport. I mean, that's continuous because you could have 78.3582 degrees. Number of goals scored in a soccer game, definitely discrete. All right, so then let's see the next one. Hi, Grace. You're back.
Now you can hear me.
Yeah, we're going over my homework assignment because this is now the Zoom live class.
That's why it's recording. Okay.
Yeah, so this is the video I'm going to be posting on Moodle tomorrow. So okay. Yeah.
Good for that.
Okay. So, but we could skip to the question that you're having right after I'm done with this one. So, okay. Number of goals scored in a soccer game, discrete. That's got to be like 1, 2, 3, 4, 0, 5, 6, 7, whatever. Number of phone calls to the math department, definitely discrete. You can't have 1.5 phone calls. The height of a child from 5 to 7 is going to be continuous. Now, the only one that might be wonky is the blood pressure one. Yeah, they're saying blood pressure is continuous. I mean, I've never heard my blood pressure to be continuous. You're looking at 120 over 80, right? Or 110 over 78, something like that. But they're saying it's continuous. So I'm just going to go change my answer. I kind of disagree with what they're saying, but oh well. We'll stick with it. All right. So Grace, which number were you wanting to see? Or were you going to stick around for the whole class or?
No, I got stuck on number 6.
6.
Yeah.
Okay. So the
So
problem,
because it has the little x and big X, so my brain lost it.
yeah, I think that's probably a typo. So here the whole length, so this is a good one to go over with the whole class. The whole length here is going to be 2. So the probability, and Wendy explains it differently in her video, but the whole length of that is 2. And they want to know the probability that we're bigger than 1.08 or you're less than 0.18. Okay, so then you got to figure out these two lengths here. So this length is going to be 0.18. This length is going to be 0.92. And the way I found that 0.92 is I did 2 minus 1.08. So that's 0.92. So then together, you're going to have 1.1. If you add those together, right? 0.18 and 9.92 is 1.1. So just take that and divide it by 2. So I'll put that in my calculator. 1.1 divided by 2, I get 0.55. So let's see. 0.55. Boom. Okay, so yeah, I don't know why they put the little x and the big X. I think it's just a typo there. That should have been a big X. Okay.
Okay, thank you.
Yep. All right, so going back to number 2. Number 2. So Estelle and Grace, y'all stop me if you have come up with any questions. Okay. So number 2, if you see these probability density curve problems, the total probability under the curve or the total area is 1. So to find probabilities, we're just finding areas. So probability that X is less than 2 is basically going to be the area of this triangle. So 1/2 times base times height is the area of a triangle. So 1/2 times 2 times 0.04. Yeah, I believe that's going to be 0.04. And then probability X is greater than 4. Well, now X is greater than 4 is going to be all this stuff from 4 up. So it's basically you got to find the area of this rectangle and add to it the area of this triangle. So the area of the rectangle, right, is going to just be base times height or length times width. So the base is 6 and the height is 0.08. So the rectangle is going to have a 0.48 area. And then the triangle, 1/2, the base is 6 again, and the height is 0.12, it looks like. Right? Because this height's 0.08, this height must be 0.12 because the whole height is 0.2. So then if we do that, I believe we get 0.36. So then add those two together, and we should get 0.84 for that one. Okay. The other way to have done part B, right? The other way to have done part B would have been to find the area of this triangle right here. Just find the area of that triangle and subtract it from 1. That would have been the other way. Okay. Estelle, you stop me if you have questions, okay?
That sounds good. Thank you.
All right. Okay, here we go. Number 3. The density curve plotted below. I want you to find the probability X is less than or equal to 31. This is a uniform distribution. So we don't really have to consider the areas. We could just say, okay, X is less than or equal to 31 is really how likely is it going to be to fall between those two numbers. So those two numbers are 1 apart. The whole interval here is 10 apart. So the probability X is less than or equal to 31 is 1/10. So they, of course, are they going to allow me to put a, nope, I got to put 0.1 then. Not going to allow me to put a fraction. Then probability X is greater than 36. Well, now X greater than 36 is going to be that part of the graph. So it's got 4 wide over 10 long, right? 4 is the length of the interval, 10 is the length of the whole thing. So that'll be 0.4. Okay. I hope that y'all are going to find this section probably the least difficult so far. I hope. Okay. Number 4. So there's a bunch of them like this, and this is a probability density. It's a uniform because the Y value is the same all the way across. Wendy goes into calculating that Y value in the video lesson. You don't really need to. It's good in some respects, but you don't really need to, because all you're going to do really is you're going to find the length between 0.76 and 1.26. So you're going to find out how far those are apart. So that would be 1.26 minus 0.76. Let's see, that's 0.5. So this length, the length from 0.76 to 1.26 is 0.5. The total length is 2. 0 to 2 is 2. So you're just going to divide the length of the interval they want to know about divided by the length of the entire interval. And that's going to give you your probability. And that's going to work for all of these kind of problems with the boxes or anything they say is uniformly distributed. All right. Okay. Scooching right along. I feel like this isn't going to be as long of a video as last week's. So the probability density of a random variable X is given in the figure below. We want to find the probability that X is at least 1.42. So 1.42 is right here. So they're pretty much asking about all of values between 1.42 and 2. They want to pretty much know that area right there. Okay, that's why she calculates the probability over here so she can use the area. But what we know, the length of this is going to be 2 minus 1.42. That's going to be 0.58. The total length of the whole interval is 2. So we just do 0.58 divided by 2. We should get 0.29. All righty. So far, so good.
So far, so good.
Thank you. All right. Number 6. Find the probability that the random variable. Oh, we did this one already with Grace. Okay, so hopefully everyone was watching that. We'll move on to 7. The time it takes me to wash the dishes is uniformly distributed between 8 and 14 minutes. So the total length of that interval is 6. So the total length of that interval is 6. The total length of the interval between 10 and 13 is 3. So what's the probability you are going to take between 10 and 13 minutes, knowing that you're uniformly distributed between 8 and 14? It's just going to be 3/6 or 0.5. Okay. Number 8. I think we did this exact problem, didn't we? You have want to know the probability is at least 1.12. So 1.12, so this length here would be 2 minus 1.12, so 0.88. So my probability then is going to be 0.88 over 2. So it should be 0.44. Make sure you read the question, because if it says probability that x is at most 1.12, then you'd actually have 1.12 over 2. Then we get into some word problems that basically are kind of work the same as the rectangle problems. In fact, these two, the denominator is the same even, because the length of the whole interval here from 50 to 52 is 2, and they want to know, find the probability that the class length is less than 51.6. So if you think about it, you got a 50 there, you got a 52 there. They want to know the probability that we're less than 51.6. So the probability that our class length is somewhere in between these two numbers. So that length is from 50 to 51.6. That length is 1.6. So we would just do 1.6 over 2. That should just be 0.8. Same exact thing working around on number 10. The lengths of a professor's classes is continuous uniform distribution between 50 and 52. Boom, denominator's 2. Because the whole length is 52. That professor's consistent. So find the probability that class length is between 50.5 and 51.9. Subtract those two numbers, and that's the class length we're dealing with. So that's 1.4. I got 1.4 over 2. So my answer should be 0.7. Okay. 9 is a repeat of what we did earlier, the dishwashing one, right? The same exact stinking problem. I wonder if y'all are going to get lucky enough to get 2 of the same problem. So we figured that out to be 0.5, right? All right. Questions, Estelle? Are we good? You can just give me a thumbs up if you want.
I think I'm good.
All right. On to number 12, everybody. On to number 12. The round off errors when measuring the distance that a long jumper has jumped is uniformly distributed between 0 and 4.2. So we have two formulas with this uniform distribution, right? So the uniform distribution, you would say that X is uniformly distributed between 0 and 4.2. So 0 is your A value, 4.2 is your B value. The mean remember we use that Greek letter mu, you just take the average of those two numbers. So 0 plus 4.2 over 2. And that should make perfect sense if you look at those uniform distribution rectangles. The mean's just got to be halfway between the low number and the high number. So 2.1 is my mean. The standard deviation, the formula for the standard deviation is going to be sigma square root of b minus a squared over 12. So we're going to do square root of b minus a is 4.2 squared over 12. I don't have my calculator out. I'm assuming that that's in everyone's wheelhouse and y'all can do that, right? So 4.2 squared over 12 square rooted, or 1.47 is what I come with underneath when I do it. Then I calculate that square root and I get 1.2124. These stinkers always want it out to 4 decimal places for some reason. Okay. Probability that the round off error for a jumper's distance is exactly 3.6. So this is one of the big differences between continuous and discrete distributions. With a continuous distribution, the theory is it's impossible to be exactly equal to a certain value. It's impossible. It's very possible to be between two values, but you cannot be the exact value. Unlike a discrete distribution, where it definitely has a probability of being an exact value. So all that is to say then that probability is 0. You can't equal a number. Then the next one says probability the round off error is between 0.2 and 3.9. Well, the distance between 0.2 and 3.9 is 3.7. So now I just have to calculate 3.7 divided by the total length of the interval 4.2. So I'll put that on my calculator. I get 0.8810 if I go to the nearest 4. Find the probability that the jumps round off error is greater than 3.34. Okay, so if you think of our distribution, we're going from 0 to 4.2, and they want to know greater than 3.34. So we basically got to figure out what portion of the line segment that line segment is. So we could do 4.2 minus 3.34. And I get 0.86. Divide that by the total length of the interval. And I get 0.2048 when I do that. 0.2048. You don't like that one, huh? Oh, I put it in the wrong box. I was gonna say, I thought that math was pretty solid right there. All right, put it in the wrong box. Here we go. So this next one, I'm gonna erase what's on there. So, pause the video, take a picture if you want, and I'm gonna erase that stuff in 5 seconds. Okay, time. Here we go. So find the probability that x is greater than 1.5 given that x is greater than 0.7. So we already know x is bigger than 0.7. So now our number line becomes this. We're going from 0.7 to 4.2. And they want to know the probability that were greater than 1.5. So they basically, we need to know that length right there, and we need to know this whole length right here. That whole length is gonna be 3.5. This length here is gonna be what, 2.7? Yeah, 2.7. So now my probability would be 2.7 divided by 3.5. So that's that conditional probability at play. So I got 0.7714 for that one. .7714. Now, these problems are interesting. Find the 51st percentile. So basically, they want to know what's 51% up the path from 0 to 4.2. Right? So we're going to go from 0 to 4.2. They want to know what's 51% up the path. If this was a different number, hopefully we have a different example where we don't start at 0, but we would just do 0.51 times 4.2 in this case. So let's see, 0.51 times 4.2, I get 2.142. 2.142. And then find the minimum for the lower quartile. Okay, so the lower quartile, that's like the 25th percentile. So we would do the same thing we did in part G, except we're going to use 0.25 times 4.2. I believe we get 1.4 for that if we calculate it. 1.4. So that would be wrong. The minimum for the lower quartile, that's from 0 to, that's actually going to be 0. That's not right either, huh? 1.05. Oh, you know, my calculation, I did 33rd percentile. 1.05. This calculation's wrong. This calculation's wrong. Holy smokes. That should have been 1.05. And I hope that didn't confuse you. Okay. So that's the way that one rolls. And I think there's
Sorry,
go ahead.
I didn't get F right, and I'm not entirely sure what I did wrong.
Okay, let's go to yours. Do you mind sharing?
Yeah, one sec. Okay. Can you see it?
Yeah, so what's your low value? Because it goes from 0 to what?
Where did I write it down?
If you just scroll up a little bit, we can.
Oh, sorry, 5.4.
So 0 to 5.4. We already know that is bigger than 1.4. So that's going to be our low value. And then 5.4 is our high value. So 4 is going to be your denominator. Now you want to know the probability are between 1.9 and 5.4 then, because greater than 1.9. So then we find this distance and we get 3.5. I think maybe you had a typo. It should be 0.875, right?
Okay, cool.
I bet you did it correct.
Thank you.
Huh?
Okay, cool. Appreciate the help.
Yeah, you're welcome.
How do I get out of it? Okay, cool.
All right. Cool. So let's see, we're on number 13, everybody. Suppose the weight of a newborn fawn is uniformly distributed between 2.5 and 3.4 kilograms. That's really little. I thought a newborn fawn would be bigger. Suppose that a newborn fawn is randomly selected. Round the answer to 4 decimal places. So the mean. So same thing we did in the last problem. Matter of fact, all these last, I think these last 4 are pretty much all the same. So we would do the 2.5 plus 3.4 over 2. 2.5 plus 3.4 over 2. So we get 2.95 for that. 2.95. And then standard deviation again, square root of b minus a. So 3.4 minus 2.5 squared over 12. So I'll make that calculation. 3.4 minus 2.5 squared over 12 square rooted 0.2598. I'm coming up with 2598. And then once again, the probability that it weighs exactly something is going to be 0. Always the case in the continuous probability. Find the probability that the fawn weighs between 2.9 and 3.3. So this width is going to be 0.4. And then the total width of the whole interval is 0.9. Right? 3.4 to 2.5 to 3.4 is 0.9. So I just do 0.4 divided by 0.9 for that one. So 0.4444. And then probability that it weighs more than 2.68. Well, let's see. Between 3.4 and 2.68, I got to subtract those two and divide that answer by 0.9. So let's see what we get. 0.08. Nope, it's going to be 0.8. 0.8. And then probably the x is greater than 3, given that x is less than 3.2. Okay, so let's draw this out. We know x is less than 3.2. X still has to be greater than 2.5. And we want to know the probability now that x is greater than 3. So we pretty much want to know that probability. So we'd have to divide 0.2 by 0.7. And I got 0.2857 when I do that. And last but not least, find the 70th percentile. So this, good. I'm glad we did this because this is different now. 70th percentile. So the length of the whole interval, here's what you're going to do for the percentile. So say you want to find the kth percentile. So you're going to go like k times the length of the interval plus the lower number. Because the length of the interval has to be that percent over from the beginning number. Okay, so 7, we're going to do, in this case, we're going to do 0.7 times the length of the interval is 0.9, because 2.5 to 3.4 is 0.9, and we're going to add that to 2.5. And that's going to represent 70% of the interval above 2.5, which is what we're trying to get after. So 0.7 times 0.9 plus 2.5, 3.13 is what I come up with for my 70th percentile. Okay. All right. I think the last two or last three. Let's see what we get here. Yeah, they're all the same. I'm gonna go over one more. And then I will stop the video. All right, here we go. Let's go over 14. Did I do 13? We did. 14. 14's got some tricky wording. Births are uniformly distributed between the 52 weeks of the year. They can be said to follow a uniform distribution from 1 to 53, a spread of 52 weeks. All right, I don't know why they're saying that, but that's what they're saying. So the mean, 1 plus 53 over 2, so that's 27. Standard deviation, square root of 53 minus 1 squared over 12. So I'll make that calculation. I got 15.0111. 15.0111. Okay. Probability that a person will be born at the exact moment that week 6 begins. Yeah, 0. Probability between 19 and 39. So between 19 and 39 is 20 weeks, right? So 20 weeks total. So this probability is just going to be 20 over 52, which is the total length of the interval. So 0.3846. Probability the person is born after week 36. So we start at week 1. Right, we start at week 1, we go out to week 53. So they want to know born after week 36. So there's 17 weeks here, 53 weeks total, 52 weeks total, excuse me. So 17 over 52. 0.3269. So 0.3269. And then probability X is greater than 4, given that X is less than 28. So basically what they're telling you is they're restricting you to that interval, 1 to 28. Now they want to know the probability that X is bigger than 4. So they want to know this probability here. So the width of that's 24. The total width is 27. So we're just going to do 24 divided by 27. So 0.8889. And then find the 46th percentile. So this is good. We got to review this again. Find the 46th percentile. So we're going to take 0.46, multiply it by the length of the interval, and then add the lowest number in the interval, which is 1. So percentile times the width of the interval plus the lower bound is going to give you that percentile. So I'm coming up with 24.92 for that one. 24.92. And then find the minimum for the lower quartile. So the lower quartile is the 25th percentile. So I would calculate it the same way. 25.25 times 52 plus 1. Let's see, 0.25 times 52 plus 1 is 14. And that would be the lower bound for the lower quartile. Okay. So that's how all this stuff works in this section. Next week's going to be a much harder week. I apologize for that. If you want to, you can start getting ahead and start working on next week, because there's 2 chapters next week. Then the week after that, we have our midterm. There's no other homework that week, so that's kind of nice. All right. That's it. I'm going to stop recording, I think. Let's see. All right, we'll see y'all later.